Hello, my name is Dylan. I'm a math teacher at St. Thomas Aquinas High School. I was also a physics tutor and provided supplemental instruction at Broward College Academic Success Center. I was also a substitute professor. I have a bachelor's in physics and a master's in math education. So let's get started. In this video, we're solving for all sides and angles for oblique triangles. To do so, you must apply the law of sines. So I'll do sine of angle B over length B equals sine angle C over length C. Now, when you have a fraction equal to a fraction, this is a proportion, and it's great to simplify proportions by cross multiplying. So it's good to remember your prerequisite algebra. And when you see a special form, like a fraction equal to a fraction, that should signal that you cross multiply. If you see a sum or difference of fractions, that usually indicates you should multiply by the LCD and so on. So in this case, you could cross multiply, especially if you're solving for the denominator. But notice how it's actually faster though, just to multiply both sides by 8. So 8 times the left side. This would be equal to sine C, but I could isolate C by taking inverse sine to both sides. Good. Next, it's important to remember this will give you inverse sine of, let's make this a decimal. You could type it in one shot, but I just want to be careful. Sine of 20 times 8 divided by 6. So this fraction is about 0.456. Next, once we take the inverse sine, that gives us the angle. We get about 27.13. Or C2 is approximately 180 degrees minus 27.13. So 152.87 degrees. So we just found C. Notice when you take the inverse sine, it gives you two angle values. Now, again, that's what should stand out to you. If you take inverse sine, this produces two values of the angle C. I think that's a great way of looking at it. Whenever you do inverse sine, that's what's going to happen. Another signal that you should have two angles is you're given side angle, SSA, which is called the ambiguous case. But again, why does SSA result in the ambiguous case, which is two angle values? Well, once we look at our resulting angles, we need to determine if our data represents 0 triangles, 1 triangle, or 2 triangles. Let's find out. So the next step, this is like your step 2. You're going to do given angle plus found angle should be less than 180 degrees. And I always write this out as a step because I don't want to forget to do it. My given angle was B, and I found C1. That would be 20 plus C1, which is equal to 47.13 degrees, which is definitely less than 180. Therefore, C1 must represent an angle inside a triangle. Given plus found would be 20 degrees plus C2, which is 152.87 degrees. $172.87, which is certainly less than 180 degrees. Therefore, C2 represents an angle inside a triangle. Now, if the sum of, for example, if the sum of B and C2 exceeded 180 degrees, then we know it must be the case that C2 cannot represent an angle inside a triangle, because once we added A, B, and C, then it would definitely exceed 180 if just B and C alone exceed 180. So that's why we still look at 180 degrees, even though we're summing just two angles. So now, step 3, we could do find angle A. Okay, sounds good. So angle A should be 180 degrees minus your given angle minus your found angle. Oh wait, but I need to distinguish between my C1 and my C2. So for each value of my found angle C1, it generates a corresponding A1. Again, a consequence of having two C angles is that I produce two A angles. Now this is confusing because a lot of students, I noticed they'd write a B1, but whatever your given angle is, it just stays alone. There's only one given angle. So this is 180 minus given minus C1. And this gives 132. Yeah, A1 is 132.87 degrees. Next, we have an angle A2, which is 180 minus given minus C2. Again, for each value of C, we generate a value of A. 180 minus B minus C2. .13 degrees. So this is the process. I like to write it out step by step. I know this is kind of silly, this step here, because we can clearly see that when we add our B and our C, it's not going to exceed 180 degrees. But if you forget that step, then you could be in a situation. And again, if one of these sums, if the sum of two angles exceeds 180 degrees, for example, if C2 did, then C2 would not represent a triangle. So then we'd only have one triangle as our solution. Okay, last step. But in this case, we have, a C1 and a C2. So finally, the last step is We just need to find the length little a. So you always go back to doing law of sines again. This is always the process. And I start it the same way. Easiest way is to do sine of my given angle, which is sine of b over the length b. And now I'll do, well, I could do sine of a1 132.87 degrees, because that should be over little a1, which allows me to isolate. Since a1 is in the denominator, this time I do suggest cross multiplying. This becomes, and you could skip more steps once you get more comfortable with it, because then you'll see how repetitive it gets, but that repetition is good. A1 times sine of 20 equals 6 times sine of 132.87 degrees. So now I'm going to divide both sides by sine of 20 to isolate A1. Good. So then we get, when you type that into the calculator, you get A1 is approximately 12.86. Excellent. Now I need to build an equation again using law of sines. I'll start it just the same. I'm going to do sine of given angle over its length equals sine of A2 over little a2. Sine given over its length. So little b was 6 equals sine A2 over length A2. Remember, lengths are lowercase, angles are capitalized. I cross multiply, I get A2 sine of 20 degrees. Notice how it's going to take the same form though. Times 6 sine 7.13. I'm going to divide both sides by sine of 20. So 6 sine 7.13, all divided by sine of 20. So my A2, once you type that into the calculator, is about 2.18 units of length. And that's the process. Two triangles exist with angles C1 and C2, with lengths A1 and A2, and so on. That's how you approach an ambiguous problem.